Welcome to The Explainer. Today, we're diving into one of the biggest, and honestly, one of the weirdest problems in AI right now. What do you do when these super smart models just start making things up with total confidence?
And look, this is not some abstract theoretical thing. I heard a story from a developer that just nails this problem. They asked an AI to write up the documentation for a payment API, and what they got back? It looked absolutely perfect. I mean, the structure was right, the examples were spot on, but there was just one tiny problem. The API was completely imaginary. The AI just invented it. A perfect, confident lie.
So yeah, there's a name for this. It's called a hallucination. And it's exactly what it sounds like. It's when a large language model pulls information out of thin air. We're talking about everything from fake product features to completely made-up legal cases. And the scary part is, it presents it all as if it's stone-cold fact, with total, unwavering confidence. Not a single hint that it's wrong.
Now, when this happens, you always hear the same advice, right? Oh, you just need to write better prompts. And sure, better instructions can help a little, but it's really just a band-aid. It doesn't fix the root cause. The real solution, and this is what we're all about today, is to stop thinking of this as a prompting problem. It's a system problem. It's about building a smarter, more robust framework around the AI itself.
So this all leads to a really big question we've got to tackle. If we just accept that hallucinations are, gonna happen sometimes, that they're just part of how these things work, then what's the next step? How do we build a safety net to stop them from actually causing damage? How do we catch these things before they get out into the real world?
Okay, so to build that safety net, first we've got to understand the why. Where do these confident lies even come from in the first place?
Well, it really boils down to three main issues. First, the AI is basically working with a frozen snapshot of the internet. It can't just go and Google something to double-check. Second, it's a master at pattern recognition, but sometimes it gets a little too creative and blends different patterns together to create something that sounds like a fact, but isn't. And finally, its core job is to be helpful. So instead of just saying, I don't know, it'll often just guess. It'll invent an answer.
Okay, so that brings us to our first technique. And honestly, it's one of the most powerful tools we have. The idea is super simple. If the AI's memory can't be trusted, then let's just not rely on it. Let's give it a cheat sheet.
Just think about the difference for a second. In one corner, you have the AI's built-in memory. It's static, it's outdated, it's pretty general. In the other corner, you have this external knowledge base. We're talking about your company's latest documents, a live database of facts. It's current, it's specific, and it's grounded in reality. This whole technique has a name, Retrieval-Augmented Generation, or RAG for short. And what it does is completely flip the script. Instead of just asking the AI a question and, crossing your fingers that it knows the answer, the system does something else first. It goes and retrieves the relevant facts from a trusted knowledge base. Then it passes those facts to the AI and says, hey, answer the user's question, but use only the information I'm giving you right now. All of a sudden, the AI's job isn't remembering anymore. It's summarizing.
All right, let's move on to our next layer of defense. The principle here is something any good journalist knows by heart. Never trust, always verify.
And this really requires a shift in how we think about this. You have to build your system with the assumption that every single thing the AI spits out is just an unverified first draft. Nothing, and I mean nothing, should ever get to an end user until it's been checked.
And the cool thing is, you can actually automate this verification process in some pretty smart ways. For example, you could have a second AI whose only job is to fact-check the first one. Or you could have your system automatically check any facts or figures against a trusted database. There's even a really simple but effective trick called self-consistency. You just ask the AI the same question, maybe 3 different times. If you get 3 different answers, well, that's a massive red flag that it's just making stuff up.
Okay, technique number 3 comes at this from a totally different direction. See, a big part of the problem is that we give the AI way too much freedom to be creative. So what's the solution? We force it into a very specific box.
I mean, look at a typical chatbot answer, right? It sounds great, it's conversational, but every little detail in there is a potential landmine. Is that price actually correct? Is the product really in stock? The AI is just filling in the blanks conversationally, and we have no idea which parts are real and which parts are just fluff.
But now, check out the alternative. Instead of asking for a nice, chatty paragraph, we force the AI to give us structured data. Something like this simple table, or maybe some JSON. We define the exact fields we want: product name, price, availability. We can even say, hey, for availability, the only valid answers are in stock or out of stock. This completely removes the ambiguity. The AI can't just invent a new status or make up a different price.
So, you see, the structure itself acts as a guardrail. By being super strict about how the AI is allowed to answer, we make it almost impossible for it to just go off the rails and start inventing things.
All right, for our last couple of layers in this safety net, it's time to bring humans back into the picture. And this really breaks down into two main ideas. First, we've got to get the AI to tell us when it's not sure about something. And second, we need a smart way to keep people involved in the process.
And this point is so important. A perfectly correct answer from an AI can sound identical to one that's completely made up. It's that false confidence that's the real danger here. We absolutely need some kind of signal, some way to know when the AI is just taking a wild guess.
So one really effective way to do this is to just tell the model, hey, along with your answer, give me a confidence score. That number suddenly becomes a super valuable piece of data. If you see a low score, like this 42%, you can build rules around it. You could automatically throw the answer away, or, better yet, flag it for a human to come take a look.
And this idea leads directly to what people call human-in-the-loop systems. Now, having a person check every single AI response would be a nightmare, right? It's just not practical. So instead, you build smart pipelines. Only the really high-risk answers, or the ones with those low confidence scores, get sent over to a human for review. It's the perfect balance, really. You get the speed of automation with the critical judgment of a person.
So when you start layering all these techniques together, the RAG cheat sheet, the verification step, forcing it into a box, and smart human oversight, you start to see a whole new picture. The goal isn't to build a perfect AI that never makes a mistake. That's probably impossible. The real goal is to build a trustworthy system, a pipeline that's designed from the very beginning to expect failure and know how to handle it.
You know, what this really represents is a huge shift in thinking. We're moving away from just blindly trusting the model and moving towards actively detecting its flaws. We're graduating from prompt engineering to something more like AI systems engineering. It's about building systems where trust is something that's earned through verification, not just assumed because the demo looked cool.
And that really leaves us with one final thought to chew on. Is the real goal here to build a perfect, flawless AI, or is it to build a perfect, flawless safety net? I think how we answer that question is going to shape everything about where this technology goes next. Thanks for tuning in to The Explainer.